and welcome to today's session on solving simultaneous equations, linear equations to circle equations. So what we're going to be looking to do, much like what we've done with our linear to linear and linear to quadratic equations, we are going to be looking to solve two or more equations where one or more are a linear equation or one or more are a circle equation. And just same as what we did with quadratic equations, we are going to be looking to use substitution to solve this. So for our example, we've got x minus y equals 6, x squared plus y squared equals 26. Of course, this x squared plus y squared, that's the equation of a circle. So the first thing that we're going to do, we're going to rearrange our linear equation to make x or y the subject. In this case, I've made x the subject, so x equals y plus 6, because when we take the negative y from the left-hand side to the right-hand side, it becomes a positive y. And we're now going to substitute in our value for x into our equation. So we've got now y plus 6 squared plus y squared equals 26. And then we're going to solve this like we would do a normal equation. So by multiplying out our brackets, we end up with y squared plus 12y plus 36 plus y squared equals 26. Now simplifying this a tiny bit with our y squareds, because we've got two lots of y squareds, that becomes 2y squared plus 12y plus 36. And I've brought my 36 from the right-hand side to the left-hand side, so my equation is going to equal 0. Because, of course, it's going to become a quadratic equation, so we need it to equal 0 so we can solve it. So we end up with 12y squared plus, 2y squared plus 12y plus 10 equaling 0. And then what I've done, I've taken another step, because I've got all even numbers in here and I'm looking for just y squared, because I might look to try and solve this by factorising. I've gone and halved my equation. Because they're all even numbers all the way across, I can halve the entire equation and it'll still equal the same thing. So I've now been left with y squared plus 6y plus 5 equals 0. This does factorise. If it doesn't factorise, if you can't see how it factorises, maybe look at completing the square or quadratic formula to try and solve this. This factorises into y plus 5, y plus 1, and of course equaling 0, which means that my y values are y equals minus 5 and y equals negative 1. Now we are going to substitute in our values for y into one of our equations, in which case I'm going to use my rearranged equation just here, because if I substitute my values for y, I'm going to automatically be solving my values for x, because that is my subject in this equation. So first substitution with my negative 5, I get x equals 1. And substituting in my negative 1, I get x equaling 5. So that means my solutions are 1, negative 5, and 5, negative 1. Now we can solve these graphically by plotting it and using the graph. Of course, as always, we want to rearrange our equation to make either x or y the subject, so we can plot and calculate values on our table of values, and then use the coordinates to plot this on the graph. But this looks like our blue line just here is our linear equation, our first equation, and this circle here is our second equation, which is our equation of a circle. Now the radius of this circle should be the square root of this number just here, which is just above 5, and as you can see, the radius of this from the center is just outside 5. But as you can see, our circle and our line intersect at 2 points, which are 5, -1, which is our solution just here, and 1, -5, which is our solution just here. And we know this is right because we've just calculated this using substitution in the previous example. So a couple of things that we just need to bear in mind when we are trying to solve graphically. If the line and circle do not touch whatsoever, do not intersect, then there is no solution. If the line touches the circle in one position, so the line almost acts as a tangent to the circle, then there is one solution. But if the line intersects the circle, crosses through the circle, then there are two solutions at the 2 points that it crosses. If you like what you see, please subscribe. Thank you very much for watching.